We're going to build off the previous days and talk about some more terminology and word problems. Now we're going to talk about something called the angle of elevation and angle of depression. Now, angle of elevation I found is a pretty easy concept for people to get because the observer's on the ground and you're looking up at something, at some object. You elevate your eyesight, you're looking up. So angle of elevation is pretty easy for people to understand. Now, angle of depression, this one is a little bit trickier. So angle of depression, the observer is up in the sky somewhere, or up on top, and they're looking down. Think when you're depressed, you're feeling down, you're feeling sad. Angle of depression, you're looking down. What a lot of people will do if they're drawing a picture is they'll make a right triangle like this, and they think that this is the angle of depression right here. That's not the case, so you'll notice that it's a completely different angle. So the angle of depression is actually above our sight line. And one thing you could think about is that if I'm the observer up here, and this is my angle of depression, if I reverse that and here's my object, the angle of elevation to my object up here, like in reverse, these two angles are the same. So you could reverse this if you wanted to do that. That made things easier. But just know that the angle of depression is above the sight line when you're working at that, because here's your sight line, or not your sight line, sorry, your horizontal line from your observer straight out, and there's your angle of depression that's formed. So let's look at some word problems, and we'll get better at this. You're at the top of a roller coaster 100 feet above the ground. So I'm going to draw that. Okay, 100 feet. Okay. The angle of depression is 44 degrees. Okay, so we're going to go downhill. And it says the angle of depression is 44 degrees. So I'm going to do this to make life a little bit easier. Draw my horizontal line. So this is 44 degrees. And what I'll do next is I'll make this my right triangle then, so that my 44 degrees is on the inside. If this is 100 feet right here, that means this also has to be 100 feet. So here's my 44 degrees. This is a right angle. Let's label our sides. Hypotenuse. This is the opposite side, which makes this the adjacent. The question says about how far do you ride down the hill? So you really have to read and see if are you trying to find this horizontal side or this hypotenuse. And since we're riding on a roller coaster, we're trying to find this red line right here. Let's do SOHCAHTOA. We know the opposite side, and we are trying to figure out the hypotenuse. And that means sine. So sine of 44 degrees equals the opposite 100 over the hypotenuse, which we don't know. So multiply both sides by x. X times the sine of 44 degrees equals 100. Divide both sides by sine 44 degrees. X will equal, and then we type that into the calculator, so 100 divided by sine 44, 143.95. Right, I just wanted to make sure I was still in degree mode. So 143.96. 143 feet is how far the ride was. Alright, example number 2. A railroad crossing arm is stuck, that's 20 feet long, is stuck with an angle of elevation of 35 degrees. How high is the arm from the base? Okay, so we have a railroad crossing arm. It says it's stuck at angle of elevation of 35 degrees. So this angle right here is 35 degrees. So we'll make a right triangle. Now, this 20. This line, or the hypotenuse, represents the arm because the arm is stuck at 35 degrees up. You know, a railroad crossing arm goes up and down. So the arm is stuck right here. This is 20 feet. And we want to know how high is it from the base, which is going to be this right here. So let's label our sides. This is the hypotenuse. This is the opposite side. And this is the adjacent side. So, Katoa. We know the hypotenuse, and we're trying to figure out the opposite side. So sine of 35 degrees equals our opposite side over the hypotenuse, which was 20. We'll multiply both sides by 20. And then I have my calculator. I'm typing in 20 times sine of 35 degrees. I get 11.47. Okay. So that is how far this arm is off the base. Alright, example number 3. It says a kite is flying 150 meters in the air and the string you're holding makes a 40-degree angle with the ground. What is a horizontal distance from you and the kite? So the kite is up here. We're down here. It's going to make a right triangle, so we got to figure out where do these numbers go. Well, 40 degrees with the ground, okay, because here's the ground down here. It's asking us what is the horizontal distance from you to the kite. Well, horizontal distance, we're trying to figure that. That's left and right. This is what we're trying to figure out. Now, it says a kite is flying 150 meters in the air. That means vertically, up and down. It's 150 meters in the air. If it would have said that the string is 150 meters, then that would have been the hypotenuse. So that's a very small distinction in this problem, that it says that 150 feet in the air versus the string is 150 feet long. Alright, so let's label our sides. We have the hypotenuse. This 150 is the opposite side, 150 meters. And then the adjacent, because 40 degrees, this angle that's 40 degrees, does not touch this side over here that's 150. And we're going to write out SOHCAHTOA. We know the opposite side, so we're going to underline the O's. We're trying to figure out the adjacent, so that is tangent. So the tangent of 40 degrees equals the opposite side, 150, over the adjacent, x, which we're trying to figure out. Multiply both sides by x. And x times the tangent of 40 degrees equals 150. Divide both sides by tangent of 40 degrees. So on my calculator, I'm doing 150 divided by tangent of 40 degrees, and I get 178.76. meters, because that's our units in the problem. Okay, we're skipping example 4 because it's a beast of a problem and I don't want to lose you guys, so I'm going to explain it when I come back. But we can do example number 5. We have a 25-foot flagpole, so 25, and it says it casts a shadow that's 42 feet. Okay. Now, we're asked what is the angle that the sun hits the flagpole. So here's our flagpole. The sun is, up here being all sun-like, and the rays of the sun cause a shadow. We're trying to figure out the angle. This angle right here. So I'm going to do this the way I described and when we talked about angle of depression, that if this angle up here is x degrees, that means this angle down here is also x. That might make things a little bit easier for you guys. So let's write out SOHCAHTOA. If this is my angle, this side over here is 25 is the opposite because it does not touch that angle. This is the hypotenuse, since the hypotenuse does not touch the right angle, which makes the sides at 42 the adjacent. And so we know the opposites, and we know the adjacent side. So the tangent of x is equal to the opposite side, 25, over 42. So then the inverse is 25 over 42. And we type that into our calculator. And I get 30.76 degrees. So we will practice this more when I return. Then be ready for questions to ask me. Like I said before, the stuff isn't hard if you've been following along the whole time and do the steps that I ask you to for these problems. When you start skipping steps, that's when you get confused and don't know what's going on. Write out SOHCAHTOA every single time. It will help you. Alright, so I will see you guys later. Bye.